So here's our question that you were to try. So here's the answer here. Hopefully you got the same thing. You were able to get that. And we're just doing our last type, which is trig substitutions. And in all honesty, we'll go back to these later, but I just want to show you briefly a couple little trig integrals. Okay, so a trig substitution is if the trig function and its derivative are also in the question. So we'll often see something so the derivative of cos is sine. So for example, if we had like sine x and then in a bracket cos x plus 5 all to the 6. This goes along with the other types as well. This is a bracket to a power, so we would call u the inside of the bracket. The derivative is minus sine, and we have that, so we want to rearrange du over minus 1. So put your u in first, drop these off, du over negative 1. And that would be u to the 7 over 7, and put your u back in. Okay, so that's the type we've already done. But sometimes it's not that obvious. So for example, if we had like sine x times cos cubed x. So you don't see the bracket when we put a exponent on a trig because they put the exponent between the argument, and that means that the whole thing is cubed. So when you see something like this, that means cos x all cubed. You could rewrite it like that if you want, but it is a bracket to a power. So we're going to call u the cos. The derivative of cos is minus sine. And that's what we have, the sine x and the dx. So if we plug that in, do your u first, so this would be u cubed, because it was cos and cos cubed. Drop these off, du over negative 1. So u to the 4 over 4. And u is cos, so cos to the 4 over 4. So that's how, like, a sine and a cos together, we can often do that. For example, what if we had sine over cos? Now this is a trig identity, that's tan, but ignoring that that's tan for a minute, you could treat this like a fraction. So in our second type, we did fractions that don't have a bracket to a power, and we called u the bottom, so the denominator. So if we call u cos, the derivative of cos is minus sine. So u is on the bottom. Sine x and the dx are going to be du over negative 1. We don't have anything left on top, so we'll put a 1. 1 over u is ln u. So we get minus ln of cos x plus c. All right, so what I want to show you here is if you had noticed that sine x over cos x is actually tan, okay, you see that? That's true, that's a trig identity. Then You could say, just from the memorized list, that this is ln of secant. But wait, why are the answers different? They're not. These answers are the same. If you remember rules of logs, which you may or may not remember, but they are important in math, if we have n ln x, that's the same as ln x to the n. That was one of the rules of logs, if there was a number in front. Now look up here. If we treat this like a -1, let's just put a round bracket to make it easier, then this would be ln of cos x to the -1, which is ln of 1 over cos x. Well, 1 over cos x is secant. So both of these answers are right because they're both the same thing. They're no different. Okay? You could actually use this as a proof that the integral of of tan is ln of secant by doing the integral using the substitution rule and getting that. Okay, that's actually a proof. Okay, there's lots of different trig integrals, and there's lots of ways that we can do trig. Something like this. The arguments are different, so we can't use substitution here. That doesn't work, but there is a trig identity. Sine 2x is one of the trig identities I said that you really needed, and that is sine 2x is 2 sine x cos x. And this is divided by cos, and now you notice they cancel. So this integral is not substitution, and it can just be done. Integral of sine is negative cos, like that. Okay? So we've seen some of these before, but just to remind you, so sine and cos are easy to do substitutions with, and you can do lots of substitutions if you have an integral and its derivative in the same question. So for example, if I did secant squared tan cubed, there's a secant squared. Secant squared is the derivative of tan. So if you let u equal tan, then the derivative of tan is secant squared. And that's what you have here. Secant squared. So we called u tan, so that would be u cubed. These drop off, du. So this would be u to the 4 over 4. And put the u back in. And you could write it either way, this way or this way. All right, we'll do more of this particular type later, so that's good for now. And you can go try all the homework questions for these, and then when we come back, we'll add on more integration techniques to this one.